The material to be able to work these problems, you already know, we've already done it, you already know how to do it, but I want to talk about some of these questions and some of the wording so that we can make sure that we're all on the right page here. Now on the first set of applications we did on the pink one, I told you I didn't care how you drew the pictures, whether you drew them where you were actually adding the vectors or if you drew them where they were all at zero. That's not really zero. That's fine. But on this one, I want you actually drawing them as the addition of vectors. And when you do that, you have to be a little bit more careful with your angle estimations and the length estimations. And so here's what I mean by that. And don't copy this down just yet because I'm going to erase this. But when it says the ship sails on a bearing of 20 degrees. Well, when I go to draw that bearing of 20 degrees, I can't draw it like that. That's more like a bearing of 45, right? Now, I don't expect you to get out a protractor and a ruler and try and make this perfect, but when you're estimating it, you need to, put it a little closer if it's supposed to be 20. Then you have to pay attention to the lengths of the vectors, right? If my first vector is 50 and my second one's 30, then the second one has to be shorter. And if you don't at least pay attention to that and try and do just like the best you can at estimating, then your picture's going to be all wonky in the end and it might just confuse you, okay? But again, I don't expect it to be perfect. Yours could look a little bit different than your neighbors. If you're careful with your estimations, it should be good enough for it to make sense to you, okay? But you just can't be willy-nilly drawing stuff. Also, the ones that we have done so far have been, the magnitude has been velocity or force, but it can, in this case here, it's going to be distance because we could also use it as distance. So, but we work them the same way, okay? So I'm going to help you draw the first one. We're going to talk about the setup and stuff, and then I want to go talk about a couple of other ones. So here it says a ship sails 50 miles on a bearing of 20. So you can go ahead and draw what I have drawn here. Actually, I might make it a little bit longer because that's about 20. That's good enough, I guess. So that means this angle here is 20 degrees. Here's my arrow. The magnitude of this vector is 50 miles. Then 30 miles further on a bearing of 80. So then I need another perpendicular here. This time my bearing is 80, so it's going to be a lot closer to what I would think of as the x-axis, but it's not going to be as long as the 50-degree one. So, oops, that kind of is long. Let's see, I got to get in front of it. There you go. Maybe something like that, okay? So then this is 80 degrees, and then this length here is 30 miles, right? So instead of having a ship and wind or something like that that's pushing it, this is an actual tracking of what you're doing, right? So you're sailing this way, and then you turn and you sail this way, and so we want to know if I just went from beginning to end, what that would be. So you have your resultant vector starts where your first one starts, ends where your second one ends. So if your estimation is decent, then your vector should be pointed in the directed towards the quadrant that you want it to be, which would be the first quadrant. And length, it's not like we're going to measure it, but that would be your resultant vector. The question came up yesterday of, does it matter what we name the vectors? And no, it doesn't. Even on the problems that we did yesterday, in some classes I used R for river and I used W for water in other classes because it doesn't matter. Personally, I would prefer for, when I'm doing it, for it to match something that's going on in the problem so I can keep up with which is which. Because in the end, they're not asking me for the vector anyway. It's more for you or for somebody following it. If you want to call them V1 and V2, whatever makes the most sense to you, it's fine. In this case, since it's the ship both times, I mean, I have, it's not like I have a ship and water. I have a ship and a ship, so the two S's might be confusing. So in this case, I might just call them V1 and V2. Right? So it means I would need thetas for both of them. I'd need the first theta and I need the second theta. So for this first vector here, what would theta be? 70, good, so 70 degrees. And what about for the second one? 10 degrees. All right. Are there any questions about how we know how to get theta? We're all good on that. Okay, so now let's do our vectors. In this case, I think I'll call them vector 1 and vector 2. So V1 is going to be, the magnitude is 50 times the cosine of 70, and then 50 times the sine of 70, right? Then V2 is going to be 30 times the cosine of 10, and 30 times the sine of 10. Now, we're not going to finish this whole problem because you can handle this on your own. But when I add these together, I can say V1 plus V2. There's nothing wrong with that. But it's also the resultant vector, so I can call it R. So I'm going to need to find the resultant vector. Then I'm going to need to find the magnitude of the resultant vector and use the correct labels. Then I'm going to need to find theta, but this is asking me for the bearing. So after I find theta, I need to find beta. And then the magnitude of the resultant and beta are my actual two answers there. Okay. What questions do you have about that? We all good on that? Now you can do the work. I was just making sure you understood the pictures and labeling. You label it however you want. Yes? I'm sorry, what? Because it says find the bearing. Okay. Okay. What else you got about this one? Bearing is beta, yeah. How would you get the bearing? Bearing starts here at 0, and you measure it this way. Theta starts here at 0, and you measure it this way. Quadrant bearing starts from north or south, and you have the north-south of the resultant vector. Yes. Yeah. All right, so let's jump down. Go ahead. Is there another question? Okay. Let's see. Let's jump down to number 4. So those were distance. This we're going to be using velocity again. And this says, because of wind, a plane's ground speed, which is the actual speed relative to the ground, might differ from its air speed, which is the speed in still air. In addition, the plane's true course, the direction in which it actually travels, might differ from the heading, the direction in which it is pointed. So if the plane is going to travel in still air, like there's no wind, there's nothing that's affecting what's happening, then if this is the heading, it's actually going to go right there. However, when the wind is pushing it, even though this is the heading, it actually ends up on this right here, which is its true course. Does that make sense to you? That's what's happening. The wind is literally pushing it. So I wanted to make sure you understood the terminology here, because on number 4 it says find the ground speed. That just means the actual speed. Okay, so actual speed relative to the ground. Okay, so find the actual speed of an airplane. The airspeed is its actual velocity, but the wind is changing that some because it could be making it faster or slower if it's pushing it or whatever. Okay, does that make sense to you? And again, we're back at velocity. The work is the same. I just didn't want the fact that it was asking you for ground speed for you to think it was like something weird or whatever. Okay. All right, now flip it over on the back. Let's look at number 7. 7 says an ocean liner has a heading of 250 degrees and a speed of 12 knots. If the ship, so it's talking about the heading, and then the ship's true course, and its speed relative to land is 10 knots. It says, what are the speed and direction of the water current? So it's giving you the heading of the ship, and it's giving you the resultant vector, and it's asking you for the information of the water, which means it's giving you the first vector, and it's giving you the resultant vector. It's asking you to find the second one. See, it even says hint, you're given the resultant vector. So instead of adding the two vectors, what are you going to have to do? Subtract. So think about what that means for your work and for what your picture would look like and whatnot. Okay, so that's what's happening on these. Make sure you read them carefully so you don't just do them exactly like you've done the rest, because you're not going to get the right answers. Okay. All right, what questions do you have? All right, good deal. So I want you working on this. I have it all worked out. I have my thetas written down. I have all it so I can check your answers. I can check your pictures, help you with that, but make good use of your time. Okay? We good? Awesome.